In this video, we're going to talk about a couple of things that aren't really related, but they're both kind of small. And that's going to be recursion and Lambda functions. Okay, so for recursion, it just means simply it's a function that calls itself. So we have recursion in C++, we have recursion in lots of languages. So I guess the good news is that there's nothing particularly unusual about how Python implements recursion. I mean, recursion is just recursion, okay? So the things we normally see as far as recursive examples are going to be things like factorials or Fibonacci numbers, things like that, okay? So we're not going to do those in particular. I think we've done those before. So I'm going to have a different problem for you to work on in class. But there are a couple of examples here. So when we're thinking about recursive functions, we always have to have two parts. Now, sometimes the base case is implied, and it's not a specific test, or it doesn't do anything necessarily. But we have a base case and a recursive step. The base case, we're checking to see if we're done, okay? And the recursive step is we're not done. Let's call it again on a smaller problem. So if you think of the recursive function that does a factorial, if you have 6 factorial, okay, your base step is if the number you're sending to the factorial, let's call it n, if n is equal to 1, then you just return a 1 and you're done, okay? If not, you have to reformulate the factorial problem to say that 6 factorial is equal to 6 multiplied by the result of 5 factorial. So we're calling factorial again on 5, okay? So it's basically how that works, okay? So you have to have a base case and recursive step. Without the base case, it just goes on forever. Without a recursive step, it's not a recursive function, okay? So here's just an example of a function called count list. So we're going to send a Python list here. Our base case, okay, is if the list is empty, okay? So there's nothing in the list, okay? If that's true, we return 0, okay? Else, we're going to return the recursive step 1 plus calling count list again on this a list 1 colon, okay? This means, remember, our lists start at 0. So the a list 1 colon is going to start with the second item and go on from there, okay? And then in the program, we're just going to use a quick list comprehension here. A is equal to A for A in range 20. That's going to give us 0 to 19. I'm going to print A just to make sure that worked. And then I'm going to print using the printf again. I'm going to evaluate this count list of A, okay? And I should get 20. Okay, and we get 20, okay? So there's some issues with recursive functions. There are things that really require recursive functions. I'm thinking in particular back to data structures where we were dealing with trees and linked lists and some of the things where you kind of have to have a recursive function, okay? But in general, although as a mathematician, I love the idea of recursive functions, it turns out they're not super efficient. And they're not super efficient because you have to create a new instance of the function every time, and that takes up a lot of memory, okay? So if there's a better, or not better, if there's a way to do it iteratively without it being just lines and lines and lines of code, then it certainly makes more sense to not use the recursive function, okay? But it is important to know, because some cases we do need it. So I was reading a website that was talking about the factorial problem, when you're doing a factorial, that the iterative version is always much faster than the recursive version. But in that case, knowing your Python makes sense, there's the math library has a built-in factorial, which is faster than in either of them, because basically it's going to be written in C++ directly. Most of the libraries are, okay? So one more example of a recursive function here, and this one is based on turtles, okay? So I'm again doing the pip install collab turtle here in my first line. I have to run that one first. And then I've got this draw square, which simply takes in a turtle and a side length, okay? And then it's going to, for the 4 sides, go forward the length of the side, turn 90 degrees, and do that 4 times, okay? So straightforward enough. Our recursive function then is going to be this nested box, okay? So in this case, we have an implied base case, okay? So we're going to say our recursive step then is, so I guess I can put this in here to make this a little more clear. Okay, so we're going to have an implied base case. Okay, if there's nothing to do, we don't return anything. Okay, and then here's our recursive step. Okay, so in this case, if the side is greater than or equal to 1, we're going to draw a square. Okay, and then we're going to call nested box again on the side that it's 5 minus that. Okay, so it's going to go down every time, and we'll eventually get to where it is less than 1. Okay, when it gets 0 or less than our negative number, then we're going to stop. Okay, so you don't always have to have a specific or a definite base case, but you have to have this if statement in any case. Okay, so then we're just creating our new turtle, initializing the turtle. I'm setting my background here, and then I'm calling the nested box. So when you do this, you're going to get a series of squares. Okay.
I'm sorry, I didn't quite catch that.
And of course, my phone is talking to me, so it always does. So anyway, so you see that's all that's doing recursively. Okay, it's going to keep going until it gets down to a side length less than 1, in which case it's going to stop. Okay, so if you have the optional textbook, there's a lot in there about doing some fractal things. Fractals are very recursive type functions, and there's some interesting stuff there. I tried the tree program, which looks kind of cool, but it didn't work well on Colab for some reason. I don't know, maybe it's something I was doing wrong. But anyway, that's the basic idea. And I could have hidden my turtle at the end, which I didn't do, but you get the idea. Okay, so that's recursive functions. So I will, when class starts, there'll be an assignment we'll work on in class for that. Okay. The other thing I wanted to talk about, again, shifting gears, doesn't have anything at all to do with what we were talking about before. But somebody had asked about it, and it is an important concept, and that's the idea of a Lambda function. If you were in the programming languages class that I taught a year ago, it seems like, I don't know, some of you were, we talked about Lambda functions, and Lambda functions are just anonymous functions. Okay, so they have no name, that's why they're anonymous, and they have to be on one line. At least I've always seen them on one line, so I'm not sure there's a way to do them more than that. Okay, so the first example takes a regular function. We have a cube function, which takes in a value y and returns y times y times y. Simple enough. Okay. The Lambda version of that would be to have this, lost my way here. Lambda cube is the name of our function. Okay. So this is the function creator in some ways. Lambda is the keyword. Y is the variable we're dealing with, colon. So this part is required. Okay. And then it just does the y times y times y. Okay, so if we do this, I'm just printing out here the cube 5 and the lambda cube 5 just to see that there's no difference. Okay, and we'll go ahead, I guess, and run this, and then we can show the output as we go. Okay, so this just shows that they return the same results. Okay, so it's just a way of doing things a little easier, I guess. Okay, although, you know, it's shorter, I'm not sure it's easier. The Lambda functions really come into their own situations where you want to do something, but you can't fit a function in there. So that's more of a better example. Okay, so here's kind of an example of that. In this example here, the second one here, is that we're using list comprehension along with a Lambda function. Okay, so allows us to do a little bit more complicated list comprehensions. So in this case, we're going to create this is even list. Okay, again, we've got the outer brackets for our list comprehension. Okay, and instead of our normal x for x in range 1 to 5, we're doing here this Lambda function argument equals x. Okay, colon, and then it's going to be argument times 10. Okay, so the x will take on the value here of in the range 1 to 5. So 1, 2, 3, and 4. So we should get 10, 20, 30, 40 when we run it. Okay, and you see here that we do. Okay, so it allows us to add, and these are simple examples, but you certainly could do a lot more with those Lambda functions. Okay, and then here's one, we're just using the if-else possibilities within a Lambda function, and we're just defining a max function here lambda, A and B. So again, we can have more than one variable, doesn't matter, comma separated. The colon, so again, the lambda, the variables, and the colon are all required. We're going to say A if A is less than B, else B, okay? And then we're just going to print out the max of 1 and 2, which will print out 2, okay? So again, this is a lot shorter, right? If we were going to do a regular max function, we'd have to say, if A is greater than B, return A, else return B. So it'd be spread out a little bit more, but just, this, again, this has more of a functional feel to it. Lambda functions are pretty big in functional programming languages. So that's kind of the idea, okay? So we're not really going to do an exercise with Lambda functions, but I did want you to be familiar with the concept, okay? So I think this will be a relatively this is relatively straightforward. I think we've seen recursion before. So if you have questions or you're getting confused on this, make sure that you ask me in class or send me a message.